Let's take a look at command line basics, identifying and understanding symbolic links. Let's take a look. So far, everything looks normal. User bin Python is a file. More specifically, we can use this file to invoke the Python interpreter. Let's look more closely at this file. In the above invocation of ls, we used the -l flag to direct ls to use the long listing format. Notice that in this long listing, there is an arrow. The arrow means that user bin Python is not a regular file. Instead, it is a symbolic link that points to another file. In this case, user bin Python points to the file Python 2.7. We can confirm that user bin Python is a symbolic link by invoking the program file. File can be used to determine the type of a file. This confirms that user bin Python is a symbolic link. Let's take a look at user bin Python 2.7. We see now that user bin Python 2.7 is an actual executable file. So, when we call Python, the system redirects our call so that Python 2.7 is called instead. Now, let's look at a slightly more complex example. We see that user bin Emacs is a symbolic link to etc alternatives Emacs. Okay, that's a little strange. Normally executable files are located in user bin, not in etc. Let's take a look at etc alternatives Emacs. We see now that we have another symbolic link. etc alternatives Emacs is actually a symbolic link to user bin Emacs24x. So, when we run user bin Emacs, the system redirects our call twice. First, to etc alternatives Emacs, and then finally to user bin Emacs24x. In conclusion, symbolic links, like shortcuts in Windows and aliases in the Mac OS, provide a mechanism for referring to another file. Symbolic links can be easily identified by using ls with the -l flag, and also by using the file command. This work was created by Lane Schwartz. You are free to reproduce and adapt this work under the terms of the Creative Commons Attribution Share Alike 4.0 International License.